In previous videos, we introduced the concept of the logarithm and we began to evaluate some logarithmic expressions. In this video, we're going to look at how to evaluate more complex logarithmic expressions. To begin with, let's do one of the more basic ones like we've previously looked at. If we're asked to evaluate log base 3 of 27, we're really being asked what exponent do we need to use on 3 to get an answer of 27. And because we know that 3 to the power of 3 is equal to 27, we know that log base 3 of 27 is 3. That's the exponent we would need to use. However, it's not always so straightforward. If we're asked for log base 8 of a half, it might not be immediately obvious to us what exponent we need to use on 8 to get an answer of a half. So we're going to follow a series of steps. First, we're going to make a logarithmic equation by setting this equal to x. Then we're going to rewrite that as its corresponding or equivalent exponential equation, and we're going to solve for x by writing both sides as powers of the same base. So let's do that. First, we're going to set it equal to x. So we're introducing a variable here. And then we're going to rewrite this as its corresponding exponential equation. 8 to the power of x is equal to a half. 8 to the power of x is equal to a half. And now we're going to solve for x by writing both sides as powers of the same base. The base we're going to choose here is 2, because you can write half as 2 to the power of negative 1, and because you can write 8 as 2 to the power of 3. Don't forget that you still have an x here. Now, we can combine these two exponents as 3x. Remember, when you raise a power to a power, you multiply the exponents. So 2 to the power of 3 to the power of x is equal to 2 to the power of 3x, and that's equal to 2 to the negative 1 on the other side. Because the bases are equal and the whole left side equals the whole right side, that means that the exponents must be equal, so 3x is equal to negative 1, or x is equal to negative a third. Now the question didn't involve an x and didn't ask us for x, so we should go back to the original question and answer it. Log base 8 of a half is equal to negative a third, and that's our final answer here. Let's do another example. Log base square root of 8 of 32. Again, we're going to set it equal to x, and then we're going to rewrite it as an exponential equation. Again, we're going to choose a base of 2, because 8 is a power of 2, 32 is a power of 2, so that seems like a good choice. 32 is equal to 2 to the power of 5. 8 is equal to 2 to the power of 3. That's still under the square root sign, and that's raised to the x. Now, that square root sign is the same as a power of a half, so we could rewrite that in the next line, and then we still have our x is equal to 2 to the power of 5. Now we're going to combine all of our exponents by multiplying them together by the power rule of exponents, so we get 2 to the power of 3 halves x is equal to 2 to the power of 5. Again, because the left side is equal to the right side, and because the bases are the same, that means the exponents must be equal. So 3 halves x is equal to 5. Moving up here, that means that multiply both sides by 2, you get 3x is equal to 10, or x is equal to 10 thirds. Again, the question didn't ask us about x, it asked us about this logarithmic expression, so we should answer like this for our final answer. So that's an approach to solving more complex logarithmic expressions.